And the focus of today will be on two groups. Okay, so in the outline today, of course, I'm actually going to be talking about the confidence interval for difference between two population proportions, the confidence interval of difference of means, and lastly, I'm actually going to focus on the confidence interval of the mean of the difference. Okay, so first, I'm gonna start with confidence interval of difference of proportions. Now, actually, what we want to do here is we actually want to construct a confidence interval estimate of difference between two population proportions. Uh, why do we want to do this? We actually want to do this, for example, we may want to find the proportion of, like for instance, maybe we're trying to compare the number of females in the United States Congress and the number of females in the Canadian House of Parliament. Okay, so if we want to do that, we actually need to obtain the proportion of females in the two assemblies. Of course, then after that's computing the proportion of females in the two assemblies, which is actually going to be the ratio of the number of females in each assembly divided by the total number of people in that assembly. And that will give you also the proportion of the characteristics of interest. Now we are actually computing that, from two populations. We may want to actually find a difference. First, we can find the difference by subtracting. So when we subtract, of course, the value we have is actually going to be called a point estimate of the difference. But you know what? The point estimate of the difference could actually be wrong or right, according to the classical approach of probability. And that is the reason why we actually need to consider what we call the margin of error. So considering the margin of error, of course, we gonna have results in an interval, because the facts remain that you know the true value of the difference will lies in the interval with the associated degree of confidence. Okay, so in, but we before we can actually do that, we got some requirements that I'm actually going to call assumption. And number one is that we should be talking about categorical response variable for two groups. So why is it have to be categorical? Because based on the example that I just cited right now, uh, since the characteristics of interest is a female, of course we're talking about gender, and of course in any parliament, of course that can be categorized into either having female member or male members. Okay. Then another requirement is that the independent random sample for the two groups, either from random sampling or randomized experiments. So the samples that will be taken from the two groups, have to be done randomly. Okay. Of course, you remember in our previous lecture, like previous my video, I actually talk about randomized experiment. I talk about and actually choose participant from population using what I call instruction of chance. Okay, so another requirement that I'm actually going to call another assumption is that we actually have to take a large enough sample from each of the population of interest, and in addition, uh, there should be at least a 10 number of success and at least 10 number of failures. Of course, you know how to do that. Just multiply the number of the sample size by the probability of interest, or we should give you the number of sources. Okay, so the confidence interval for is but the requirement for for constructing a confidence interval for difference of proportion is different from that of a single uh, proportion. You remember the other time when we're dealing with a single proportion, we actually said that MP should be at least 15, okay? And then N into 1 minus P should be at least 15, okay? But uh, uh, when you're considering the two population right now, we expect that N1, P1 has to be at least 10, okay? And N2, P2 as well has to be at least 10. And not only that, N1 into 1 minus P1 have to be at least 10, and N2 into 1 minus P2 has to be at least 10. So this is the requirement for the two groups, okay? But this is just a requirement for a single proportion, okay? This is for single, uh, if you want to do the confidence interval for a single proportion, that's what you're going to do. But if you want to do confidence interval for, two groups, okay, you could consider two groups, okay, where you have two proportion, of course, that is a requirement. So now you need to take that into consideration. There are different requirements in terms of what the number of successes or the number of failures have to be before the construction of the confidence interval for one group. Of course, at least it has to be MP has to be 15, or N into 1 minus P has to be 15, and for two groups it has to be at least 10. Okay, so I'm actually going to move now. Those are the requirements in case you are asked about, the assumptions underlying constructing the confidence interval for either one or two populations. Okay, so we are moving mathematically now. So let us have a picture of the situation. Like I said, we actually from population, we are considering two population. In population one, we are actually going to have, we're going to select a sample size randomly, which is denoted by N1. And after that, we are looking for the characteristics of interest, which is X1, which is the number of successes in the sample that was selected. Then from there, we're going to obtain what we call the sample proportion, which is the ratio of the number of characteristics of interest to the sample selected. And of course, when you get P1, of course, you can get Q1, which is 1 minus P1. Okay. Now you're also going to do the same to population 2. Okay. For population 2, these are the attributes or, the notations. Okay. So we got that for population 1 and for population 2. And of course, the sample size we are choosing from the two populations have to be kind of random and at the same time independent. Okay, so if that is what we have, then the next thing we can actually talk about is to pull the proportion. We got P1 and P2, okay? And how can we pull the proportion? Of course, pulling the proportion is just to add the number of successes in the two groups divided by the totality of the sample size, okay? Divided by the totality of the sample size. Can you just give me 1 second? Okay, so thanks for that. I think I'm back now. Okay, so like I said, this is the formula that you're actually going to use to get the pool sample proportion. Okay, by adding the two characteristics of interest from the two groups divided by the total sample size, and of course that is actually going to be denoted by P bar. Now, after having your P bar, of course you can get your Q bar, So which is 1 minus p bar. Okay, so the next thing we are actually gonna do uh, after that is well, what is the formula to obtain uh, the the confidence interval? Now, if you take a look at what I have here, this is the true value of the difference. Okay, we call that the true value of the difference. This guy here, okay, that is the true values, the true value of this difference, and we believe that the true values of the difference will lie between uh, the lower parts and the upper parts. Of course, if you look at the lower parts, of course, we are actually subtracting the margin of error from the estimate of the difference between the two proportions from the two groups. And of course, in the this is the lower part, this is the upper part. And of course, in the upper part, we are adding the margin of error. Okay. And then what is the formula for the margin of error? The formula for the margin of error is actually going to be that. Okay. The formula for the margin of error equal to that. So, and I'm actually going to tell you that there are two things in this formula. Okay. So this is going to be the z value. Okay. This is going to be the z value, and this guy is going to be standard error. Okay. That is the standard error of difference of proportion. Okay. So which means the margin of error is just multiplying the standard error of the difference of proportion by the z value. Okay. When you do that, you're actually going to get the margin of error. Okay. So the margin of error right here is what you're actually going to subtract and add to uh, the estimate of the difference between the sample proportion. Okay. You can see that now. So that's exactly what you're going to have. Okay, so we want to have an example right now. The table below lists results from a simple random sample of front seat occupants involving a car crashes. Use a 0.05 significance level to test the claim that the fatality rate of occupants is lower for those in the car equipped with airbags. And of course, you're given the data as follows. You have an airbag available. This is a cross tabulation table, where we are cross-tabulating whether the airbag is available or not against, the fatality. Okay. And of course, you can see the occupant fatality when the airbag is available, that's 41. And when no airbag is available, that is 52. And of course, the total number of occupants for when airbag is available is 11,541. And the total number of occupants, when there is no airbag available was 9,853. And of course, this is actually one to test the claim that the fatality rate of occupants is lower for those in car equipped with airbags. And that's exactly what we want to test. Testing that, we actually also want to construct the confidence interval, okay, for that. Now, and what you're actually going to do is you need to first, if you want to start, you're going to actually investigate whether the requirements underline, constructing a confidence interval hold or not. And of course, uh, you know, you need to identify, to see whether the number of successes or the number of failures in the two groups have to be at least 10. Okay, just like what I said before in the requirement. I'm going to show you. Okay, you can see that now. So when I said a large, enough sample size N1 and N2, so that in each sample, there are at least 10 successes and at least 10 failures. Otherwise, you may not be able to do that if you don't really investigate. Okay, so when you investigate and everything is fine, then the next thing you're actually going to do, um, you are asked to use 0.05 significance level. Okay, but that is actually going to be a test. Okay, so what you are asked in the question is actually going to be actually a test. But right now we are not working on tests. or all what we just want to do right now is just to construct a confidence interval of the difference of the, the proportion of the fatality in the two group, whether they have a airbag available or not. And that's exactly what we want to do. Okay. And in doing that, probably we want to construct a 90% confidence. Okay. So in constructing the 90% confidence, of course, the Z value is going to be 1.645. I think I told you before before. Now, we can actually first start by calculating uh, what is actually going to be our P1, or the estimate of the P1 and the estimate of the P2. And of course, when you get the estimate of the P1 and the estimate of the P2, and of course, the sample size and the Z value, then you will be able to obtain what I call the margin of error E. Okay. But you know what, how am I going to get my P1? Of course, if you go back, the P1, the proportion of fatality when the airbag is available is actually going to be 41 divided by 11,541. And of course, the proportion of a fatality when no airbag is involved is actually going to be 52 divided by 9853. Okay. And then when you do that, and that is what we are actually having right here. That's for P1, and this is for P2. Okay. And of course, when you do 1 minus P1, you're actually going to get a Q1. When you do 1 minus P2, you're actually going to get a Q2. And of course, what you have right here is actually the sample size. And what you have right here is actually the sample size. Okay, the sample size from the first group, the sample size from the second group, and of course, putting everything together with the. So this guy here, whatever you get here is actually going to be the standard error of the difference of the two proportions. It's actually going to be the standard error of the difference of the two proportions. So when you multiply that by the Z value at 90% confidence interval, you're actually going to have what I call the margin of error. Okay. And that is actually going to be the margin of error. Now, you've been able to get the margin of error, and then the next thing you can do, then you can actually go back to the formula right now, and you can make use of the formula by trying to, plug in the values of the pcap 1 and pcap 2, and the margin of error, and at the end of the day, you're actually going to arrive at this. Now, when you take a look at what I have right now, what we're trying to say is that we are actually 90% confident that the true values of the difference of the proportion, okay, will lie between a negative 0.0023 and negative 0.00000218. Now, when you take a look at this, you're actually going to see that in this interval, you cannot have a zero in this interval. Okay. And when there is no zero in an interval, it's indicating that the two populations are not the same. Okay. It means the number of fatality recorded when airbag is available is actually different from the number of fatality recorded when there is no airbag, when there's no airbag at all. Okay, because when you take a look at the interval does not include zero, but situation whereby the interval includes zero, and that is when you're going to say there is no significant difference between the fatality rate, where the fatality, for the two groups. But from what we're seeing right now, of course, there is a significant difference, because if you take a look at the interval now, you're actually going to see there is no way you can have a negative. I mean, there's no way you can have zero between a negative and negative. Okay, you can only have zero between negative and positive number. Okay, but right now you are not going to have zero, and that is actually giving an indication that the fatality recorded when airbag is available, and then when airbag is not available, are not going to be the same. Okay, so that was why I said the confidence interval limit do not contain zero, imply that there's a significant difference between the two proportions, and the confidence interval suggests that fatality rate is lower for occupants in cars with airbags, than for occupants in cars without airbags. Okay, so the confidence interval also provide an estimate of the amount of the difference between the two fatality rates. Okay, so in case you actually uh, want to, in case you actually want to take a decision uh, regarding comparing fatality, recorded. Now, the next thing I have to talk about now, we've talked about the confidence uh, interval, you know, for the difference of proportion, and the next thing that I want to talk about now, or we want to focus on the means. Okay, what a situation whereby we actually want to we are not only interested in just getting the point estimate of the difference of means, but we are interested in also constructing a confidence interval of the difference. And of course, the reason why we do that, because a single value could be wrong or right, and therefore to be at the safer side, we're actually going to consider constructing the interval and the confidence interval for that. Okay, so that is exactly what we actually going to do. But you know what? There are different kinds of you know ways that you can actually do that. Okay, we, like I said, we're going to take an independent sample from the two population, and after taking the dependent sample from the two populations, we actually want to know whether does the standard deviation of the two population exist. If it is unknown and then and not assumed to be equal, okay, that's going to be the first part. If the two standard deviation from the two populations are unknown, okay, they are not known, and then they are not assumed to be equal, of course, the formula that we're actually going to use. Uh, I'm going to show you right now, but let me first consider the notation for that. Okay, we don't. We are taking you know uh, sample from two independent population. Uh, we after that, of course, what we want to actually compare is the population, the mean of the first population with the mean of the second population. If you take a look at this guy here, that is going to be notation for the population mean, which is the true mean of the first population. And of course, this is the standard deviation, the sigma 1. And of course, this is the sample size that will be randomly taken from the first population. And this is the sample mean, the mean that we obtain from the sample that was taken from the first population. And this is the sample standard deviation. Okay. Now, in a situation whereby the population standard deviation is not available, okay, where it is not known, then it means we are actually going to estimate our standard deviation. Okay, and how can we estimate our standard deviation? Of course, we're actually going to get that result from the sample. Okay, so which means both the mean and the standard deviation will be computed from the sample, and that is why we call them sample mean and sample standard deviation. Okay, so we're also going to do the same thing for the second population. Take a look at that. What we did to the first population, we're actually going to do the same to the second population. Okay, and when we do that, we want to construct a confidence interval. And of course, the confidence interval is actually, this is the formula that we actually going to use for the confidence interval. Okay, of course, we are having the difference of, this is the point, you know, the point estimate of the difference of, the sample means from the two population. Of course, we need to, well, what is going to be the formula for E, which is the margin of error. Of course, I'm actually going to show you the formula uh, right now. And you know what? Since the standard deviations are not known, and we're the one that we are determining the standard deviation, of course, the distribution, we are not going to be talking about z-score anymore. Okay, we're actually going to be talking about T distribution. Okay, can you see that now? Initially when we're dealing with the proportion, the difference of proportion, of course, what we have as part of the margin of error was actually z value. Okay, but right now, because of the fact that the standard deviation of the two population are not known, and of course they are assumed not to be equal, of course we're going to use a t distribution. Okay, so now the standard error of a difference of proportion in this situation is actually going to be this guy here. In case I ask you to find the standard error, okay, that's exactly what you're going to do. This is the standard error, and don't forget, multiplying the standard error by the t value. Okay, of course, that will actually give us the margin of error e. Okay, the margin of error will be subtracted from the estimate of the point estimate of the difference of the of the means, and of course it's also going to be added to that, and you're actually going to get a confidence interval. And you know what? Because we're making use of the t distribution, it means we are the parameter for the t distribution is actually going to be what I call the degree of freedom. Okay, so how do we get the degree of freedom? For the two population, when you take a sample size from each population, of course, the degree of freedom is actually you're going to subtract one from each of the sample size that you choose from the two population, and of course, if you want to obtain the value for t, you are actually going to get a value for t, putting into consideration the level of significance alpha and the degree of freedom. Of course, my TA, we actually walk you through this to get this in the lab. Okay, so we want to have an example right now. Okay, an example, a headline in USA Today proclaimed that men, women are equal takers or talkers. Okay, that headline referred to a study of the numbers of words that samples of men and women spoke in a day. Okay, so given below are the results from the study. Use 0.05 significance level to test the claim that the men and women speak the same mean number of words in a day. Okay, does there appear to be a difference? Okay, so you know, uh, an headline in USA actually claim that men and women they talk equally. Okay, they are equal talkers. Okay, and we actually want to investigate whether this claim is true or not. And when you take a look at what we have right here, of course, a sample size of 186 men and 210 women were randomly selected. And of course, we actually recorded the mean number of, the mean number of words. Okay. So, of course, the mean number of words for men was that, and for women was that. Okay. Based on the sample. And of course, the we computed the standard deviation, the sample standard deviation, from the two group, because the standard deviation was not actually known, and they were not actually known, and they are not equal. Okay, so in this situation, of course, we're actually going to make use of the formula that I showed you the other time. So we want to use the formula we want to use is the confidence interval for difference of means when the populations and deviations are not known, okay, and they are not assumed to be equal. Okay, so if I want to do that, because of the fact that you want to test at a 0.05 level of significance, then it means if you want to construct the confidence interval, then the confidence interval is going to be 95%, because I told you the other time that our 5% level of confidence determines the level of statistical error. Okay, if you're able to mislead five, you mislead the audience, 5 times out of 100, then it means you have your level of confidence is going to be 95. Okay, and that is why. So we actually want to construct a 95% confidence interval estimate of the difference between the mean number of words, okay, spoken by men, and mean number of words spoken by women. Okay, that's exactly what we want to do. Okay, so like I said, we need to, for us, obtain what I call the pickup, the what is it called, the x, we already have the data, and we can actually obtain the margin of error. And of course, if I want to obtain the margin of error, of course I'm actually going to plug in the values of my standard deviation from the two population and the sample size. And of course, that is what I mean. Of course, uh, the square of the standard deviation is actually going to be variance. And when you take a look at this guy right here, how did I get that guy there? Of course, uh, I'm actually going to you can my TA is going to walk you through how you can obtain the value, or I mean of t in the in R. Okay, so the value of t, where you actually you're going to use the level of significance, and after using the level of significance, then you're going to use the degree of freedom as well, and that will actually give you 1.972. And of course, when you get 1.972, you're actually going to multiply that by the standard error. Okay, this guy here, the one in the square root. Okay, when you find the square root of that, it's going to be standard error. So by the time you multiply, then you have your margin of error. And of course, the moment you have your margin of error, don't forget that the mean that you obtain for each of the group, that they give you from each of the group, is actually this one. So then you're just going to plug in your values into the equation, and of course, you are done. Now take a look at what I have right now. So what is going to be your conclusion? Right here, we're trying to say that we are 95 percent confident that the true difference of the true mean, the true difference of the words spoken by men and women, we actually lie between -2141.9 and 1048.9. Now take a look at that. When you have interval between a negative and a positive, okay, then it means zero is actually going to be included. Now, if a zero is included in an interval, okay, if zero is included in an interval, and that is giving that is giving an indication that the two populations are the same. Okay, so which means there is no significant difference between the words spoken by men and spoken by women. So this is actually, confirming what the USA Today actually, suggested. Okay, look at that. The headline in USA Today proclaimed that men and women are equal talkers. Okay, so based on the fact that if you take a look at what we have here right now, the other interval actually includes zero, because the zero lie between negative and positive. Okay, so that is actually confirming, their stand, that men and women, you know, they are equal talkers. Okay, so the next one that I want to talk about right now, how do we construct confidence interval for difference of means when uh, the two standard deviation are known. The one we just did right now is when the two standard deviations are unknown. Okay, so when they are known, how do we actually construct? Therefore, the formula is actually going to change. Now, take a look at what I have here right now. I think the difference in the formula, in the margin of error, you are not going to use T anymore. You're going to use Z. Okay, you're going to use Z when the two population standard deviation or the two population variances are known. Okay, you're going to use Z instead of T. Okay, and not only that, take a look at this guy here. It's not going to be You're not going to be focusing on the sample variances or sample standard deviation anymore. So what you're going to be focusing on is going to be population variances and the population standard deviation, and that is what those symbols actually depict. Okay, so like I said, there's going to be a slight change in the formula. Okay, now this is the formula right now, and of course, if I want to write that formula in full, then this is going to be uh, the formula. Okay, can you see that now? So if we want to, if the variances, if two variances are known, if the population, I mean the two population variances are known, or the two side population side deviation are known, this is the formula. Of course, what I'm trying to talk about is that this guy here is E, what I call the margin of error. The other time, you see that now? That's going to be the margin of error. Okay, so, and another thing, another reason here is that assumption is that the sample size have to be at least 30. Okay, that should be 30 as well. Okay, so let's now see. Let's work out an example on this. Uh, don't forget, the the standard deviations of the two groups are known. Okay, okay. Now a study was conducted, and two types of engines, A and B, were compared. 50 experiments were performed using engine A and 75 using engine B. Okay, the average gas mileage for A was 36 mpg and 42 mpg for B. Okay, find a 96% confidence interval on the mu B minus mu, where mu A and mu B are population mean gas mileages for engine A and B. Assuming populations and deviations are that, you consider now. So it means in this question, the population standard deviations are given, they are known. Okay, so we're going to use. Let's first collect our data. Okay, you can see this is for the first group, group A, and that is for group A, group B. Okay, you have the sample mean, you have the population standard deviation, and you have the sample size. Okay, and you are asked to find 96% confidence interval. Of course, the 96% confidence interval will mean the level of significance, the level of statistical error will be 4%. Okay, then you're going to do alpha divided by 2. And when you do alpha divided by 2, of course, you're going to have 0.02. And of course, when you check the z value associated with that, that will give you 2.055. And of course, if that gives you 2.055, then you can actually use the formula. Okay, so which formula do you want to use? Of course, you're actually going to use the formula right here. Okay, you're going to plug in, those things into the formula. Okay, so when you plug in that into the formula, and of course, this is what you have. You can see that now. You plug in that, and at the end of the day, you have this as your result. Look at that. Okay, that is lie between positive and positive. Okay, the mean of the difference of the difference of the mean is actually a line between positive and positive, and that is actually giving an indication that there is no there's a significant difference because of the fact that you can never have zero in this interval. Okay, you can have zero in that interval. Of course, there's a significant difference in them. So therefore, you're going to say you are 96% confident that the true value of the difference. Okay, the difference of the means will lie between 3.4224 and 8.5776. And of course, it means they are statistically, different. Okay, so the next part that we want to talk about, we are still on, you know, uh, two groups where we actually want to construct the interval estimation for means. Now, a situation whereby the standard deviations are assumed to be equal. Okay, when the two standard deviations are assumed to be equal. Okay, so what are we going to do? Okay, if there's an assumption that two standard deviations are assumed to be equal, of course, or the two variances are assumed to be equal, of course, we're going to make use of what I call a pool variance. Okay, the formula is actually going to change, only that this guy here needs to be computed. That's what we call the pool variance, and of course, the pool variance can be computed using the formula here before we do anything. Okay, so we need to first obtain the pool variance, and when you are pooling variance, of course, this guy here, you are going to be given the two sample variances. The two sample variances are given, but only that the two population variances are unknown, but they are assumed to be equal. Okay, when they are unknown and assumed to be equal, then you're actually going to pool the sample variances. Putting the sample variances, of course, this is the formula that you're actually going to use. Okay, so after using this formula, then you're going to plug in your results. You're going to find the square root of that, and you're going to plug your results in there. And of course, and another thing I wanted to take note, in the T, the degree of freedom is actually going to change. The degree of freedom is actually going to be N1 plus N2 minus 2. Okay, because you need the degree of freedom. It gives a level of significance to be able to figure out the value of T. Okay, and don't forget the value of t is what you're actually going to multiply by the standard error. Okay, that is the standard error. So when you multiply that, automatically that is actually going to give you your e. Okay, so this guy here is actually your e. Okay, what in a situation where examiner asks you to obtain a margin of error when the two population variances are assumed to be equal. Okay, they are unknown and they are assumed to be equal. Of course, the margin of error, so that is the formula you're actually going to use for the margin of error. And of course, for the standard error, okay, in that situation, the standard error is actually just going to be that. And don't forget, you need to get your pool variance. This is a formula that you're actually going to use to get your pool variance. And of course, if you want to get the standard, the SP is actually going to be the square root of the pool variance that you obtain. Okay. Now, having know that, let us now have an example. Suppose the farm equipment manufacturer was unable to gather data for 100 days. Okay, using the data they were able to gather, they will still like to compare the downtime for the two machines. Okay, the data they gather is shown below. Okay, now look at this word, look at this statement. Assuming populations and deviations are equal. Look at that. Okay, assuming standard deviation, population standard deviation are equal, then it means the formula you're going to use have to involve a pooled variance. Now take a look at that. You are given this data for population one, for group one, and you're given this data for group two, and they ask you to construct the 95% confidence. Okay, now if you want to compute the 95% confidence, of course this is a, you're actually going to make use of the formula. Can you see that now? And don't forget, I said you actually need to first obtain your pool variance. Okay. So, and of course, your pool variance, you're going to plug in the values that you're giving sample variance and the sample size. Plugging in that, we actually give you a pool variance of 10.267. Okay. Then you find the square root of that, you're actually going to have a pool standard deviation. Okay. And after getting a pool standard deviation, then you're going to plug in into the formula, and when you plug in into the formula, then you are done. Now take a look at what we have right now. What can you say? You know, the difference there lies between a negative and a positive. Okay, and that means the interval is actually going to include zero. And if interval includes zero, then it means we can conclude that mu1 is significantly different from mu2 because the interval includes zero. It means there's no significant difference. Okay. So that is how, you know, the moment you understand the question, of course, you'll be able to know the appropriate formula that you're actually going to use. Okay, so that is the third scenario. And then number four scenario is when the two population variances are unknown and they are not equal. Look at that. They are unknown and they are not equal. Okay. Now we have a different formula that we're actually going to use. Look at that. Okay, that is a different formula we're going to use. The only thing that you're going to take note is that the degree of freedom, you know, will be different from the degree of freedom of the pool, the one we pulled the other time. Okay, so look, the four of us need this to, you know, determine the degree of freedom. Okay, and here you have in the degree of freedom, you know, in the formula you have the two sample variances and then the sample size taken from the two group. Take a look at that. Okay, after getting your v, that is actually what you're going to use as a degree of freedom to get the value for the t. Okay, so this is a situation whereby uh you know, the variances are unknown but they are not equal. Okay, so I've defined four scenarios today. Four scenarios, you know, when you are talking, when you want to construct confidence interval for the difference of for difference of means taken from two groups. So make sure you understand each of the scenario. Okay, look out for that in a question, and then that will determine the formula that you're actually going to use. Now, the last objective for today is actually the inferences from the match pairs. Okay, match pairs. You know, we have been talking about independent samples, but right now we want to talk about dependent samples. Situation whereby you are taking uh, information from the same participant, maybe before and after, stuff like that. Okay, so how do we compute the mean of the difference? In that situation, we don't talk about difference of means, but we talk about mean of the difference. Okay, maybe in a company there was intervention, and then uh before intervene, maybe what is the way they, maybe intervention is that they boost the morale of workers by giving them incentives. Okay, and you actually want to compare situation, before they were giving incentives, what was their performance, and after giving incentives, what was their performance. You want to look at the difference between the two. Of course, you are using the same set of individuals. In that situation, we're talking about dependent sample. And that was why I said here we want to construct a confidence interval involving the mean of the difference of the values from two dependent population. Is no longer going to be independent. It's going to be dependent because we're using the same set of individuals. Okay, so and then with dependent sample there is some relationship, uh whereby each value in one sample is paired with a corresponding value in the other sample, and that maybe you're talking about reducing weight of some participant, and then you now want to compare, uh actually you want to compare the, maybe you use you know a certain you give them certain drug that can actually reduce their weight, and then you now compare before using the drug and after using the drug, you compare their weight. Okay, so stuff like that is going to be paired. Now in that situation, I'm actually going to compute what I call D, and D is going to be the difference between the two values of a single match pair, maybe the difference between before and after. And then after that, of course, I'm actually going to have more than one participant. Of course, I'm going to compare. Maybe if I'm talking about weight right now, the mean weight. Okay, so what was your, I'm going to subtract the mean weight of before using the drug. I'm going to subtract, then after using the drug, that is going to give me the difference. And if I'm going to have a lot of differences because of the fact that I'm using more than one participant, then from there I can find the mean of the difference. Okay, so this guy here actually represents the mean of the difference. Okay, so after that, this guy is the population mean of the difference, but we are not going to be, we can only estimate that, okay, by taking a sample size. Okay, therefore this is what we're actually going to get from the sample. Okay, that's what we're going to get from the sample. Okay, so and after getting there from the sample, then we can also calculate the standard deviation of the difference, D, for the peer sample data. We can calculate the standard deviation for that as well. Okay, after that, we want to actually construct a confidence interval for the match pairs. Now, the formula that I'm showing you right now is what we're actually going to use. So what we're trying to say is that the mean of the difference, the true mean of the difference, lying between this guy here and this guy here. Of course, you are subtracting the margin of error from the mean of this, from the sample mean of the difference, and you are adding the margin of error to the sample mean of the difference. And of course, what is the margin of error in this situation? The margin of error, this is the formula you're actually going to use. So let me tell you this, the formula is split into two. If you take a look at this guy, that is the standard error. We call this standard error of standard error of the the standard error of the difference, the standard error of the difference. Okay, the standard error of the difference, and this guy here is the t value. Okay, that is the t value. Okay, now multiplying the two will give you the margin of error. Okay, see that now. So the values of t can be obtained using a statistical table, and of course it can be obtained using R. Of course, my TA will actually walk you through that. Okay, so let us now have an example on that. Okay, now take a look at the example that I'm showcasing right now. the weight kilogram measurement of students in their freshman year. Okay, we want to consider the April weight with the September weight. Okay, and because of we're using the same set of individuals, okay, the same person has these two values, only that we measured the weight at different months. Okay, the same person. That is why it is paired. Can you see that now? It's the same person. Now, so that is a mean weight. Okay, we're talking about the fresh. We're talking about the freshman year. Okay, now we want to see whether they're actually going to lose weight, okay? Because they're actually going to be studying, and and that's why we want to see whether that could have effects on their weight, whether they're going to lose weight or they're going to gain weight or stuff like that. And that is the reason why. So if you want to have the difference now, so it means I'm actually going to have the April weight minus September weight, okay? April weight minus September weight, because April weight minus September weight, so subtracting now, 66 minus 67 is going to be minus 1, and 52 minus 53 is going to be minus 1, or 68 minus 64 is going to be 4, and 69 minus 71 is actually going to be minus 2, and 71 minus 70 is going to be 1. Okay, that is the difference. So this is a D, that is the difference that we talk about. Okay, so but we have a requirement that needs to be satisfied. Of course, the requirement is just that the samples have to be dependent. Okay, that is the values pair from each student. Okay, although a volunteer study, we proceed as if the simple random sample and deal with this in the interpretation. But you know what? This we are dealing with we're dealing with a dependent sample because we're using the same set of individuals. Only that we are actually taking measurements in two occasions. Okay, so now we want to construct the 95% confidence interval estimate of the population mean of the difference. Okay, now which is just the difference between the April and the September weight differences of college students in their freshman year. Okay, what we're going to do, you need to first get the mean of the difference. Of course, are you going to get the mean of the difference? What you're actually going to do, D bar is actually going to be summation D divided by N. So which is more or less like you're going to do minus 1 plus 4 plus minus 2 plus 1 divided by, how many is that? Divided by 5. Okay, you find the mean of that. Okay, so then you're going to get your result. Finding the mean of that, we actually give you 0.2. Then you find the standard deviation of that, we give you 2.4. Of course, 5 freshmen were used. And of course, then you can actually get your T value. Okay, so your T value, that's going to be 2.6. Then you are set to get the margin of error. Okay, now the margin of error, of course, you're going to multiply your T value by the standard error. Of course, the standard error is just the standard deviation of the difference divided by the square root of the sample size. And of course, that is actually going to give you that. So you got 3.0 now as the standard error. Now, if you get 3.0 now as the standard error, now you are set to obtain the confidence interval, okay? Because that will enable you to get the, what is it called, the lower bound and the upper bound, because you're actually going to subtract the margin of error from the mean of the difference. Then you're going to add it to the mean of the difference. When you do that, this is exactly what we are saying. Can you see that now? And at the end of the day, this is what you have. Now, if you take a look at the interval right now, the true value of the mean of the difference actually lies between minus 2.8 and 3.2. And of course, you can see 0 lies in that interval. Okay, and when zero lies in the interval, then it means there is no significant difference between the mean weight of the freshman in the college, in the 2 months considered. Okay, there's no significant difference because of the fact that the interval actually included 0. So, and of course, in conclusion, I said we are 95% confident that the limit of 2.8 kilogram and 3.2 kilogram contain the true value of the mean weight change from September to April. In the long run, 95% of such sample will lead to confidence interval limit that actually do contain the true population mean of the difference. And also take note that this interval does not include zero. It also indicates there's no significant difference between the mean weight. Okay, so that is what I actually have for you today. If there's anyone who need clarification, who want to ask question, of course you can meet with me during my office hour. Okay, so I actually want to thank everyone that may probably attend my lecture, or I mean that will probably watch the video. And like I said, in case you need clarification, you can actually reach out to me. Okay, so until Monday that I'm actually gonna come your way again. Make sure you stay safe and have a good day. So bye for now, guys.